Welcome to the Idea Land podcast, hosted by Ravi Kamati Reddy. PJ Lamberson is an associate professor in the Department of Communications at UCLA. He has a PhD in mathematics from Columbia and previously taught on the faculty at Northwestern and MIT. PJ's research involves computational social science, where he develops and uses tools to study how social connections shape human behavior.
How's your esports game? Did you have to put your Minecraft on pause for that? You look like you're esportsing it up today.
Oh yeah, exactly. I know. These headphones.
I'm just glad I got a chance to catch you. I know because you're so busy and you're working on like amazing things. You're like the one from high school that when everyone thought was going to go do amazingly smart things, and then you went and did amazingly smart things, and that's what you're up to. Just to catch people up, can you just give a short summary of what you're working on in your background, a little bit of how you got there, and I'll poke and prod?
Yeah. So I got my PhD in math. I was studying pure math, and by the time I was getting to the end of that, I decided that I really love pure math and it's beautiful and cool, but I wanted to do something that was more relevant to the real world, I guess, and that I could talk to other people about, which is not true. Neither of those things are really true for doing pure math at that point. So I ended up doing a postdoc at University of Michigan studying like what they call complex systems, which are basically like where you have lots of interacting things at kind of like a micro level that produce some kind of pattern or behavior at the macro scale. And I was studying the diffusion of hybrid vehicles because Ford Motor Company sponsored my postdoc, and they were interested in like what was going to happen with the hybrid market. Yeah. So I actually spent half my postdoc working at Ford and half of it at Michigan. That was 2006 to 2008. So
what was that like? What was that like for hybrid vehicles and for Ford? It's so interesting to I didn't know that, actually. You never told me that.
Yeah.
What's it like working for like a huge Fortune 100 company trying to be innovative?
It was really interesting because I had a kind of good situation because there was somebody who was fairly like decently well placed in the company. Like he was the manager of like a whole unit of Ford. There was called like their analytics unit. And he was like the champion for my postdoc. And so basically like I got to go to Ford, and like anybody who worked anywhere related to him was just instructed to like answer any questions I had. And I could like go around the whole, like go from person to person and just like ask them like, what do you do? What do you do? And it was really mind opening because I hadn't been in a business situation like that before. And like Ford is such a big company that like, you know, if they choose to like use a certain type of material or something, it can affect the global price of that commodity, you know, like when they change, when they change like how much of a certain metal they're going to use, they have to think about like, you know, most companies don't have to think about affecting the total like global demand for something.
Global supply chain.
Yeah. So, I mean, that was pretty interesting. And then, I mean,
do you think they all thought you were just there as like a consultant to see who's going to get fired? Do you think that's why they were like scared to talk to you? Because you're walking around and you're like, what do you do again? It's like just some weird office space type consultant.
I mean, at that point, I was so young that I don't think that they had that fear of me. Although maybe, I mean, that is your stereotypical like consultant age right out of college, you know, just doesn't know anything.
Right.
And, I do feel like there maybe were a few of them who were a few employees who felt that they had better things to do with their time than answer my questions. But almost most of the people were really fun to talk to and told me all about whatever they were working on. And and then I mean the other thing that happened while I was there was that this was also right at the beginning of the financial crisis, and then like the automakers were in a huge crisis at that point. And so about halfway through my postdoc, pretty much like half of the people that worked I worked in a building called Research and Advanced Engineering, and almost all of the half of the research and advanced engineering people took like buyouts for their job. And so all of a sudden there were 50% of the workforce in that building.
Wow.
And at that point, like, it's not like there was less work to do. It was just that all the work that had to be done was being done by half as many people. So they were pretty much they were now too busy to talk to me at that point. And so that, in many ways, that kind of ended the Ford part of my postdoc. Because the main person that I worked with took a buyout, and everybody else was just strapped for time. So I pretty much went back to Michigan and finished up my work there. But
were they like, "Hey kid, do you want a job?" You know,
you never offered me a job. No, I mean, I don't think they were doing much hiring at that time. They were more on the trimming at that point.
What did you feel like? Do you feel like you learned? Did it reinforce like some of the stereotypes that we all think about companies that big? Because I've never worked for a company that big, right? But I have. It's funny because Kat's favorite movie, I mean, I'd say in her top 5 is Ford v Ferrari. If you've ever seen that, I don't know if you've seen it.
I haven't seen it
with Matt Damon, because she loves the story, right? That like the big guy going against the small guy, and it's like I'm gonna solve this engineering problem by just throwing billions of dollars at it and crowd you out, and still like the small guy comes out ahead in some ways because it's this boutique automaker versus Ford, right? And everyone's like, well, Ford can't make anything pretty or fast, and it's like, no, I'm pretty sure they can, right? I'm sure if they just like focused on it, they can like, it becomes a line item in a really large budget. And that's kind of what they did. And so it's just like that logistics of trying to do this kind of, entrepreneurship in a huge business like that. Was that what the hybrid or alternative power kind of stuff was within Ford?
That's a good question, and I don't think I got to see I wasn't involved in the engineering side of things, But I was trying to understand where the market was headed and whether or not hybrids were going to become just like a little niche, or whether it was going to become kind of like an add-on that would happen to would every vehicle be able to come in a hybrid version down the road. And in particular, Bill Ford had made this commitment. He was the CEO at the time. He had made this commitment that they were going to produce X number of hybrid vehicles within, I forget how many years. And when he made that commitment, I guess he didn't ask anybody if that was reasonable. And so a lot of people were like, that's not reasonable. And they wanted to know, was that possible that the market could bear that? So I didn't see that much of the kind of that engineering, innovation side. There occasionally there were some things. So some of the people that I were working though with were really interested in sustainability, and they did have some kind of really far out ideas. I remember they had this kind of thing where it was like a car that you would drive it on local streets, but then the idea was that there would be this kind of monorail sort of thing that would exist on the freeways, and so when you drove onto the freeway, instead of your car would attach to this rail system, and you could then let go of the steering wheel and just enjoy your coffee for while you were on the freeway, and it would prevent accidents and all this kind of stuff. And they had these cool mock-up drawings of it, but I don't think that ever went anywhere. But so people were
we're not.
I haven't seen that happening yet.
Yeah, given that I can't buy one right now. It's the weird thing about driving. Right? It's the most amazing thing to ever happen to the human species, but it's also the most miserable thing to ever happen. Right? It's simultaneously both of those things.
Totally.
It's it enables cultures to mix from across whatever. So you went back and finished your postdoc, amidst this kind of very bad luck time, right, where this financial crisis was going on, and then where did you head off to kind of after that?
After that I went to MIT, and I was a faculty member there for it was 3 or 4 years. I kind of am losing track right now, but I was in the management school there, Sloan, the management school, with a group it's called the System Dynamics group. So they're all mathematical modelers who have been doing a certain style of mathematical modeling they invented it there basically. And that was also eye-opening because I'd never been in a business school before either, and I was teaching MBA students, and I got to learn from all the people there. So both Michigan, all these places were really great learning experiences because I was with Michigan was kind of actually the beginning of complex systems. They had a group there that had started complex systems as a sort of school of thought way before I got there. But so I got to learn from like those guys, and then at MIT from the system dynamics people, and it was all really fun.
So, PJ, like when it's like the word theory in science, there's like a scientific, that word is used very differently by scientists.
Yeah.
I feel like there is this whole, box of stuff here that you're saying the word complex, and to the average person, I think we can all think of systems that are complicated. But when you say complex, I think you're referring specifically to something else, like a different bounded set of problems, right? Like a different problem space. Can you describe what that means to you from a mathematical or physics level?
Yeah, definitely. And that's totally true, what you said, that there's a differentiation between complicated and complex in this world. So we think of complex systems as ones where behavior at some type of macro scale or aggregate scale is produced by interactions of smaller units at some kind of micro scale in such a way that it's not obvious, I guess, that macro pattern might emerge from those micro interactions. So we kind of think of it, we use this word emergence, that the macro behavior emerges from these micro interactions. So examples like that are really simple would be like a school of fish or flocking birds. Those units, they don't have like a leader that says, "Hey, everybody get in line. Like, all the birds, like you go here and follow me." They're just on their own, somehow kind of like queuing off of one another, and they collectively create this emergent behavior that then, so in both of those cases, actually like solves important problems, biological problems for them, whether it's like wind resistance or a predator avoidal or avoidance or whatever. So those are great examples of complex systems. Ant colonies, like can do these amazing things like build bridges and all these things, even though, the individual computational units that are doing those calculations are just ants who have almost no computational power in their brains. So. And if you start thinking of it like people are like this too, cities and culture and everything comes from all these just interactions of people.
So it's the idea that, like, if you can reduce these systems to really simple systems, like you're talking about these individual, I think you guys call them agents, right? Or you would call them these individual participants in these systems. Like, if you understood them really well, then you could predict how the larger system would evolve to some level of accuracy. Is that the idea?
Well, in some ways, part of the idea is that actually you can't, like, there's these sort of are like non-reductionist systems. So, at least in some cases, you have to understand not just what kind of like an individual ant does, but you have to understand the interactions between the individual ants, basically, and sometimes the network of who they interact with. So there's some kind of middle scale that some kind of structure that determines who's interacting with whom, and then these rules for how they affect one another, and then that's what produces this collective behavior. And lots of times it's like, when we say like, well, you could predict what it's going to do, one of the things that's, I guess, a hallmark of these kind of complex systems is that like to predict what they do really means to kind of give like a probability distribution or a notion of like what's possible that they could do, but to know exactly what they're going to do in any one particular case is oftentimes very hard because there's a lot of like what we call path dependence. So this idea that that kind of little micro fluctuations, like little things that happen early on, can like push you down different paths and to different outcomes, which is in contrast to, say, like classical economics, where like microeconomics you think of as just there's supply and demand, and in regular economics, like there's just kind of one equilibrium, and no matter what happens along the way, you're like everything gets sucked into that equilibrium where supply equals demand. And that's just determined by the cost of the goods and how much of it people want. And nothing can throw you off into like a different equilibrium. But in these complex systems, you can end up with a market example is like the VHS versus Betamax competition. We ended up with VHS, but you could have ended up with Betamax, and it all kind of depended on a bunch of small things that happened early on in that. battle. So that's another example. So what we can say as scientists oftentimes is we can say, well, it's either going to end up as VHS or Betamax, but it's really going to be impossible to predict which of those is going to happen. So we can kind of narrow down a class of outcomes that are possible, but not necessarily a specific one.
So it's pretty obvious from you talking about this that I can think of probably 5,000 off the top of my head, different systems in different areas of our lives, right? I think all of us could. There's so many situations that involve so many different agents. So whether we're buying on Amazon or like consumer choices, I think is what you were getting at, or physiologic systems and so on and so forth. But one of my questions is, so what systems do we understand really well versus what are still like in this category of it's just way too much interaction going on to where we're just really poor? So like, I guess where do you plot these things on a scale? You mentioned like the 2008 crash. Are we finally understanding economics to the point where we can model it well? And I mean, I'm aware of George Box's quote, right, about how all models are wrong, but some are useful. But like, how useful are we, and how good are we right now?
Yeah, that's a really good question. I think that we are still not great when it comes to humans. I think the social problems are the hardest ones of all to crack. Like there's this saying, it's not rocket science, which is supposed to mean like something's not hard, and we kind of joke in this field. One of our the kind of leading scholars in our area is this guy Duncan Watts, who always says that rocket science, we're actually really good at rocket science. In rocket science, we can do what we want to do. Like if we have a problem, we land a helicopter on Mars, we can fly it around, we can send space shuttle or what I don't know whether they're called crafts out to Pluto to take pictures of it, which is millions of miles away. We can do those things, but if you try to think of any big social problem, I mean, there's no social problem that's been actually solved, basically, even though people are constantly saying oh yeah, the healthcare system, that's not rocket science, right? They're right. It's not rocket science. It's way, way harder than rocket science. If it was rocket science, we'd have that totally nailed by this point. So that is to say that a long way of saying that the social problems we still have a challenge with. I mean, I think that we made progress in understanding certain things. One of the things that we've understood a lot more is why things are hard to predict, and we've able to be able to put bounds on the predictability of things. So, in marketing and stuff, a lot of people want to understand why do certain things go viral, and at this point, at least within the domain of complex systems folks, I think we can say that it's just it's actually unpredictable. It's not just that we don't have good enough data. It's that there's so much randomness in this system that you cannot predict accurately ahead of time, what things are going to go viral. And I think that's progress, right? It's not the answer maybe a lot of people wanted to hear, but it means that you can stop throwing away your money after a problem that can't be solved. And we have better luck in the physical or biological realm. There are people who actually study schooling fish and flocking birds and stuff, and they've done amazing things in those areas where they can build robot fish that look like real fish, and then they can substitute them in and change their behavior and watch how all the other fish react and do really cool stuff with that. And there's people who are doing stuff on the brain, because your brain's a complex system, right? It's a bunch of neurons all wired together. There's actually was some stuff, a lot of the more recently in the news with the COVID and everything, a bunch of the modelers who do forecasting for what's going to happen with disease spread are doing these types of models. And so I think that a lot of them proved pretty accurate in terms of where things were going to spread, how fast things were going to spread. what kind of interventions were going to be the most successful. There's people who study the genetic components of these diseases too, who, like, really early on, I saw a paper come out that was predicting all these kind of other areas of the body that might be affected by the virus. And at the time, they seemed really wild. Like, I forget what some of them were, but now we have seen actually, oh yeah, that can happen. Like, it's not just like a cold that's really bad. It's also can get into other parts of your body. I mean, the effects. So I think those predictions bore out over time. Disease, I think, is one of the areas where we've actually made some big progress. There were people working on this back in the HIV AIDS epidemic who, like, a guy named Carl Simon, who was like one of my mentors at Michigan, did really cool work that basically changed the way that we understood that AIDS was spreading in the early days, and completely revamped our focus on preventing that. So those are areas, I think, it's a lot.
So we're at a crazy time with respect to that, right? So I just love to get a data dump from you. Just so, where do you feel like, this is almost a year onwards, right? What models, what worked and what didn't? Like, just like looking back at this whole thing, because it would have been weird if we talked about this a year ago, because we wouldn't have had enough information to know how things were going to go. And I feel like there's two sets of problems, and I'd love your input on both. So obviously the physiological or the pathophysiological effect of COVID and its spread and its mutation rates and its ability to splinter off into different, to speciate, if you will. I know it's not the exact right word, but into the different variants which have effects. However, the other question I have about this is really about something that concerns me much more, which is the infodemic. So even if we had perfect knowledge of the virus and its ability to spread and infect and cause these complications, our inability to persuade people correctly on the right behaviors or predict the magnitude of what's going to happen just seems like a horrible setup for the next thing that could be an epistemic risk for us as a species. So what did work? Like, was this an opportunity or a dress rehearsal for scientists in your space to go, this is actually in a weird way what we've been waiting for, because now we can apply these models and test the results? Did that happen?
Oh, that's a great question. I think on the first question, on the physiological spreading question, that totally did happen. And I think it's still happening. Like, there are really interesting models. Actually, the same guy who did the AIDS stuff, Carl Simon, and his co-author James Koopman at Michigan have done some stuff about predicting going forward what's going to happen with the vaccinations, mutation rate, etc. And it all depends on how fast our immunity wanes and how much genetic drift there is. If there's sort of any little bit of both of those, then we can make a prediction for the future now that some variant of the coronavirus is going to be with us for a long time, and we're going to have lots of little outburst spikes that are going to come back year after year, and the frequency of those just is going to depend on how fast those the immunity wanes and how frequent that drift occurs. But when it comes to the social side of things, so this is something that we know could happen, and we see it happen. In some ways, like in political models or models of opinion formation, we see this happen a lot, this kind of polarization that everybody talks about. It's but as far as like the solution to that, I don't feel like we are there yet. There's like things that we know on the kind of individual level that seem to work, and that's not necessarily really complex systems research. It's more persuasion, I guess, or psychology. But and that's, I guess, the best that I know. I do know that there's a book that just came out that I would like to read that I haven't had a chance to yet, but that is my understanding is probably the best.
Nick Christakis' book about it?
I mean, I think Chris Sachs's book is going to be really interesting as well about just kind of the societal impacts. But there's a book by a guy named Chris Bale called "Breaking the Social Media Prism." He's a sociologist at Duke and who's done a lot of great work in this area. And I understand from the blurb that it has some optimistic outlook, that there are things that can be done to help with this. I mean, I think that I don't know how much it's going to be useful, but all of the research that I have seen about these things, like about the misinformation and so forth, really indicates that it's a very small proportion of the population that is spreading this misinformation. Actually, like, you think that it's everywhere, but I recently saw a talk that looked at it wasn't a huge data set. It was 16,000 Twitter users. But what was really nice about this data set and why it was a little smaller was that these people were they were actually verified real people. They were verified using voter registration rolls. And normally on Twitter data, you don't know if you've got a person or a bot or a company. I mean, a Twitter handle could be Ford, or a Twitter handle could be Ravi Kamathareddy. And,
right.
That's those are very different things. But these were real people, 16,000 people. And of those, I think 80% of the COVID fake news articles were spread by 16 people. That's one in 1,000. Yeah, like 0.1%. We're spreading 80% of the fake news information now, and it was still reaching more people. It was reaching something like 1% of the population. But so, like, that seems like a problem that makes it more tractable in a way. Some of these problems, because it's not as pervasive, or it's not like everybody like you might think it is.
So you just have to know which of these 16 people, or which of this really small cadre of people would have a high probability of saying or doing, quote unquote, the suboptimal thing, to set that off.
Maybe, yeah. I mean, that's an idea for sure. But the other problem, and I mean, this is like this is also something that we know a lot about. It goes back to this kind of VHS versus Betamax in a way. You end up with, when you take VHS versus Betamax and you put it into into kind of like a structured network in a way where people are not just paying attention to everybody, but people are paying attention only to certain people that they're connected to. Then instead of ending up with just everybody using VHS or everybody using Betamax, you can end up with these groups of people where some people are using VHS and other people are using Betamax, and they're separated out, right? Which is what we have in lots of cases, like with Macs versus PCs, or like why we have different electricity standards in Europe versus here. And that's not really like antagonism. It's not saying that, despite what Macs and PCs like do, again, joke about each other, it's not like they really, like, the people who are using them don't typically have true animosity towards the other side.
Right. You don't know you don't know PC people and Mac people. And trust me, I know some that almost gone to blows over the kernel. Do you know OS 10 as a Unix kernel? Did you know that? How do you not know?
Okay, yeah. I mean, some people take it a little seriously, but so we expect that to happen. We expect there to be differences, and like there to be these kind of seas of social areas where people have different beliefs. But I think what's problematic is, like when what becomes the dominant belief in one area is something that's really detrimental to society, like behaviors that, for example, allow the spread of a deadly virus. And the fact that came to be the dominant belief among a certain part of the network, like, from this like research on kind of like the viral unpredictability of what goes viral. I mean, in some ways, it's very unpredictable that would be what went viral in that part of the network, and it's in some ways, kind of some kind of randomly triggering events led that to happen. And it's tempting to point fingers, possibly accurately, at certain individuals who might have, promoted those beliefs. And if they promoted some other beliefs, then that whole population probably would have believed something else. Which is to say, like, really, that it's not something intrinsic. Like the whole, like, we don't want to wear masks, we don't want to get distance from people. That's not some intrinsic belief that population had. I don't think. Is my opinion. I don't think if you had gone back and asked them before the pandemic and before certain political figures or whatever had said, this is what your group is going to converge on.
Polarized too.
Yeah. If you had said, if there's a pandemic, would you be willing to wear a mask? They're not going to. They don't want to say, like, no, man, masks suck. Like, ahead of time. It's just that's what happened to coalesce on. And I think this happens all the time. Like, there's this great paper called I think it's called Why Liberals Like Lattes, and there's tons of things like this that correlate with political beliefs. Like, for example, that liberal people are more likely to prefer like a fancy coffee drink, which probably has nothing to do with being liberal. It's just that there's kind of these segregated populations and we influence each other. Yeah, and then we end up converging on something. And what it could have equally turned out that conservatives were the latte drinkers and liberals were, I don't know what the conservatives drink, but or
I don't know.
Yeah.
that's flipped on several things, right? I mean, it's flipped over the last 25 years on I can think of a couple prominent areas where that's changed, like climate change, right? I mean, if you look, political conservatives and Republicans were very much into climate change. The original, if you look at congressional hearings and stuff on the matter, it was like the Republicans were like, oh, this is a very responsible thing to do. And if you ever read Jonathan Haidt's book about the moral underpinnings of like conservative or liberal beliefs in the United States, it's pretty interesting. So it begs the question: how do you know which one's causing which the effect, right? So it's that I think it was Seth MacFarlane from the creator of Family Guy, and they're like, dude, your stuff is really racist and it's sexist, and these jokes that are on Family Guy, which are pretty offensive, but are funny because they're hitting on some core stereotype or something that we've all experienced, and we can all laugh at it or we can take it seriously. But he was saying, hey, look, we're not influencing or creating, we're these belief systems. We're not at the genesis of this. All we are is a mirror. We're a mirror to you. So when we see social networks and these memes go across, how much, or the masking like you're talking about, how do you know that it's not something that was actually a inbuilt, which started what, right? Were the influencers just marketing something or were they amplifying something that existed, or were they actually truly creating something novel?
This is a super hard problem in our area, and it's like gone back for a while. It's actually sometimes called the reflection problem, which is to identify basically. So when we see something like taking off, there's three classes of explanations, but maybe I should say this. A better way of saying is when we see that there's clusters of people that are behaving the same way. There's three things that could explain that. One is that it's spread from person to person, that there is influence, and it has to do with social influence. Another possibility is that it has to do with preferences, and we choose to be connected to people who have similar preferences to us. So, the conservative people will prefer to not wear masks, and they prefer to be friends with other conservatives, and so that's why we saw conservatives not wearing masks. And then what's the third possibility? Let me think. I'm blanking now for a second. Oh, the third possibility is that it's something exogenous that's correlated with our friendships. It's hard, so maybe it's like we're friends with people. So that could be that because we're friends with other conservatives. Because we're conservative, we all listen to the same news program, and the news program said don't wear masks, and so we decided all to not wear masks. So there's something correlated with both our friendship and that causes our behavior. And disentangling from data, which of those three things produce the pattern we're seeing is really, I mean, so we've been able to prove that under certain assumptions, it's impossible to disentangle these two things. In other words, if you just see what people do over time and who they're friends with, there's no way to know which of these three things did it. So to actually understand which of these three things did it, you've got two options, which is one to get data not just on what people did and who they were friends with, but actually to like somehow probe individually why they did what they did. It's one option. Another option is to make more assumptions. So you can make some assumptions about exactly like kind of how exactly people influence one another. So for example, you might assume that I adopt a behavior once some threshold number of my friends adopt that behavior. That's an assumption that says, and if I assume that everybody acts that way, then I can estimate how much these different things played a role. The best thing you can do is, if you could run an experiment, if you can actually control who's friends with who's friends, or control what information they receive, but in most of these real life circumstances, you can't do that. So that leaves us like in a tough spot. I mean, lots of times we don't know.
Right. So where are we with being able to predict? Actually, no. Let me ask something else that's going to take us in maybe a direction. So in the 60s, there was this paper, right? I think it was his name, Wigner, who wrote that paper about about the unreasonable effectiveness of mathematics.
Oh yeah.
So it's like, why does math work so? Okay, so you can either take two stances on this, right? You can either say the Max Tegmark way and say, no, the universe is just intrinsically mathematical, so it works really well, or you can take the side which I kind of more gravitate toward, which is the Stephen Wolfram way, which is, no, there's irreducibility and there's complexity and everything's an agent in this huge Conway's game of life, and it's not clear. It's like, actually, when we think things are really mathematically sound, they're not, because we can't even solve things, like we don't have exact solutions to lots of problems. Like you talk about rocket science, but like the three-body problem, you still have to approximate that, right?
Yeah.
It's not something you have exact solutions to, and that's like a simple gravitational problem. So where do you stand on this? And I feel like your area of complexity is kind of on the battleground, right? Where it's like, is math working for this? Is it the right tool? So where do you? I'll just let you take it from this.
Definitely, I've been asked that question, but not for many years. Like I used to when I was an undergraduate, I took a class from this guy named Saunders McLean, who was like in his 90s at the time, but he's like famous for he invented he invented this whole like branch of mathematics called category theory, which was like a super cool way of thinking about, it's kind of like a meta mathematics in a way. And like every third, he was sort of forgetful at the time, like about every third class he would begin with this question, like, so why does math work, and like, yeah, the students, we were all just like, oh, why don't you tell us? I mean, but
seems like a trick question.
Yeah, I don't know. It was something that clearly, like, he just bothered him, though. And, oh, God, I wish I had a good answer. Where do I stand? I mean, I haven't even thought about this forever. I don't know. I think I always joke to my students, like, when I'm teaching, I always say, like, I'm not a religious person, but if I was, it would be because of the central limit theorem, not because of, like, like that's something really amazing, like that nature, like, somehow works in this way, that everything.
Explain the central limit theorem.
Okay. I mean, the central limit theorem basically says if you take random variables and add them up, it converges to a normal distribution. There's like a couple assumptions. They have to be independent and kind of identically distributed. But the amazing thing about why does the central limit theorem make me think there might be a higher power is because you can take. Yeah. It doesn't matter how the initial stuff, whatever initial stuff you're talking about, if you add it up, you still get no normal distribution. So, like, let's say, so an example might be, like, let's say I take, like, 100 people and I count all the hairs on their heads and add them all up. And then I do that thousands and thousands of times. The distribution of, like, numbers of hairs on heads in these sums will be normally distributed. But if I did the same thing and asked people how many siblings they had, it would also turn out to be normally distributed, even though these are like totally different things to start with. And it really just like doesn't matter what you start with. Everything converges to this normal distribution when you add it up, as long as they're independent, which I'm assuming that like the number of hairs on my head doesn't impact the number of hairs on someone else's head. So those are independent. And so,
it could have at one time. It could have, a million generations ago.
Maybe.
Who knows, right?
Yeah.
I mean, evolutionarily.
They could be somehow linked, but they're, it's, and that's why you see approximately normal stuff all the time. Like if you look at distributions of male heights or female heights, it's like roughly normally distributed because of this. And, and the normal distribution in particular, to me, like stands out as amazing because it's like this totally, as you know, like the equation for it is like really hideous equation, and it involves pi, which is this terrible number, but that just happens to be the ratio of the circumference to diameter of a circle, and it involves e, which is like another terrible number, which, well, I mean, the thing that's bad about pi is like that besides like, so many people might know that pi is irrational, meaning like you can't write it as a fraction. And so its decimal expansion goes on forever and never like falls into a nice repeating pattern. But it's an even like kind of worse type of number, which is called a transcendental number, which means it's not the solution to any polynomial equation. You can't write down an equation like x squared plus blah, 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 where pi is the solution, which is not true of like many other numbers. Like the square root of 2 is irrational, but it's the solution to the equation x squared equals 2. So,
right.
But pi is not. And, in our normal life, like most of us, there's only 2 transcendental numbers you ever encounter. Those are pi and e. But it turns out actually that there are many, many more transcendental numbers than rational numbers, or most numbers on the number line are actually transcendental numbers, but you just never run into them.
That seems like something that you can prove like easily, but that like is just astoundingly weird, right? I remember the first time, because it was in college when I read like the whole this whole treatise on like Gödel's theorem, right? And
Yeah.
I refused to believe it. I remember it was me and my friend Paul I was like this just. It didn't seem like it seemed like an interesting idea, but there's no way you could prove it. You know what I mean? Like, so it just doesn't seem. It also seems like for a mathematician, it's like a thorn in your side.
Right.
It's like something that it's like what you wish you could uninvent or unlearn.
Yes.
It's like, oh, we wish this wasn't a thing.
Right.
Because one thing I don't understand about that whole treatise is. What are the implications of it? Does it have any actual implications? Does it stop you from doing anything in math?
No, not really. I mean, no to the last question. Does it stop us from doing anything? I don't think I've ever seen anybody think like, oh, well, we're not going to be able to solve that incompleteness theorem. There's like problems out there that we're still trying to solve that have been unsolved for a long time, like the Riemann hypothesis or something. But I don't think people are saying, well, the reason we can't solve that is just because of incompleteness theorem. We just think we haven't figured it out yet. I'm sure that for somebody like who's into the real like logic area of mathematics that produces things like the incompleteness theorem, it probably has like real implications for their work. But in the rest of math, I think we just kind of kept going. And didn't worry about it too much.
So, PJ, what are your thoughts? I mean, there's so many ways you can approach social networks. And I know you've done work in like tipping points and things like that, right?
Yeah.
But it seems too simplistic to ask you, hey, are you for social networks or not? It seems more interesting to ask you, how useful are they as a source of not just entertainment, but of research data that's reliable enough to where you can start getting better at building models that are more predictive or more useful?
Yeah.
I mean, don't they represent at some level this metaverse of human psychology? and human behavior? And why doesn't it, and how different are they? Are the way Twitter works and ideas spread through something like Twitter very different than how they spread through Facebook? Or does there seem to be some kind of meta language or model that all these networks use, and even including analog networks, like, just if you went back 200 years, just how ideas spread through cultures and people traveling?
So to answer your first question, I think that it's huge for social science research, the existence of what we call digital trace data, which includes social media data, but all kinds of other data, cell phone data, is revolutionizing the way that we do social science and the amount of things that we can understand. Duncan Watts, who I mentioned earlier, compares it to what the telescope was for astronomy. We can now just see things that we could never see before. And so Galileo invented the telescope, and all of a sudden could figure out, hey, wait a second, the Earth revolves around the sun, and this is how planetary motion works and everything. And, having all this digital data is making it so that we can see things that we really just were impossible to see before at scales that we could never see them. And so it is leading to lots of discoveries. And I think that it's also, there's been a lot of calls in our area for what we kind of call more problem-focused research. So to really try to address actual problems that need solving. And I think that's a really beneficial way of thinking about the future of our research. That's kind of taking hold. And so it's been great for us on all kinds of different research fronts. How much our online behavior mirrors our offline behavior depends on what kind of questions you're asking, and there's certainly differences between networks, between Twitter, Facebook, Instagram, whatever it's going to be. But I think there are fewer differences than we might expect between. There is this congruence between our behavior in these networks and what we saw in analog networks before. So in some ways, like if you look on Facebook, for example, and look at the kind of structure of our friend networks on Facebook, well, yeah, they're very different than in some respects, they're very different than what our network of so quote unquote real friends are. I'm sure you and me and many people are friends with a bunch of people on Facebook that we kind of only vaguely remember who they are. But
right.
But when you drill down into, say, the set of people that you really interact with on Facebook, or you look at subsets of that network of people, you can look on Facebook and say, okay, did these people ever appear in a photo together on Facebook, or things like that? Those networks look just not only like what our offline networks will look like, but there's been research on what our offline networks might have looked like millennia ago. So some people have done work on hunter-gatherer tribes in Africa, and who we assume kind of behave similar to hunter-gatherer tribes thousands of years ago, and their social networks look not that different from our social networks in a way. So I do think there are some things that are the same, and that are probably somehow dictated by that. Part of it goes back to the fact that in evolutionary time, these networks haven't existed very long, right? So our brains haven't changed the way that we think, the way that we've evolved to behave and are the same. We just have these different tools. What does change, though, massively, I think, is the collective behavior, because you just all of a sudden have wired people up in this way that they weren't wired before. So you didn't change the people. Our brains are still the same, and the way that we might interact with the people right around us are the same. But if you change how those people are connected, then the macro behavior totally changes. Just like disease is a great example. Our immune systems haven't changed, viruses haven't changed. That from thousands of years ago, but when the Black Plague spread through Europe, it took it took years for it to make its way across the continent. When COVID came out, it took, months for it to make around the globe. That's not because the virus is different. It's not because people's immune system is different. It's because the network of who we connect is different. And that changes tons of things. That's why things like political revolutions like happened in the Arab Spring can happen. Probably not because of anything that happened kind of in terms of people's discontent with their leaders, not from anything that happened with the way the leaders were behaving, but just because of the way that people could communicate. Like all of a sudden you got people hooked up in a way that they can talk to each other and coordinate and spread information, and then it spreads. So.
Yeah, it's interesting. I mean, it's because it could be such a conveyor belt of both good and bad stuff, right? So it's difficult to say, oh my God, is it net good or not? It's like, I don't know, or is communication in general net good or not? I don't know if you have a strong opinion about it. But what's fascinating is this incessant, I don't know if it's a generational thing. I feel like when we were growing up, I mean, you and I didn't go around in high school thinking about who the influencers were or whether we wanted to be an influencer. And I'm not saying that doesn't exist. I mean, popularity exists in any kind of social setting of human beings. But at the same time, I feel like it's different, right? I mean, if you look at me? I don't think so. I don't think so. I think I may have been a connector. I mean, our high school was really weird, right? I think it was very atypical than most schools. We didn't have the Midwestern, we had the groups of people, but everybody was pretty cool. It was actually very weird. Everybody was just kind of okay with everybody else, right? It was kind of a very interesting multicultural mix.
Yeah.
It didn't have like the jock nerd hierarchy scale thing. That's the stereotype, and I think, yeah, we were very different. So I don't know what went into making that different. But my point being, like the 14-year-old TikToker right now who lives or dies by the count on the view count. Like, what do you think about that? This kind of focus on these specific metrics. I'm not so sure that we're even measuring the right metrics, but they're clearly causing huge swings in mood and helping people plot their behaviors at a really weird, impressionable age. Like, how much should we be worried about that? How much are you worried about that for your kids?
Yeah. Well, so first of all, this goes a little bit out of my area of like scientific expertise. So I want to say I'm speaking as a normal person now, which is to say that, I think it's pretty bad. It seems pretty bad to me. And I see, like, I teach as a professor, I teach college age kids, and I see this with my students, and it, I don't know if it's just that I'm getting old, but it seems like it's getting worse. I have this sense of that my students have more anxiety, and I get more and more cases where a student, is suffering from depression and some kind of mental issue is interfering with their ability to be a productive student. And yeah, I feel like these networks have a role in that. And partially, I think from the scientific side, again, this gets back to this kind of unpredictability or arbitrariness, like, that, a person's kind of popularity or the success in some way or whatever metric you want to measure by, that has this big degree of randomness to it. It's not like how to say this, but it's like, if you fail on Twitter or whatever, that doesn't mean you posted something that was a failure, or in a way, it just probably means it was bad luck. And so, like, people's kind of...
How sure are you about that? Because a lot of money goes into this, right? I mean, there's an insane amount of attention to people who are consuming stuff, but also people trying to sell, and to solve this very question. Like, what makes something viral? What makes something, someone popular? I can think of one example, Stat News, which is like the medical news site.
Yeah.
It's an online magazine, and they talked about Dr. Jha, and how he became like the voice, the online voice of COVID, like a trusted voice.
Uh-huh.
And then I can think of like Brett Weinstein and his wife, right, who've been talking about the lab leak hypothesis for a while now, and how that has swung through social media in terms of the valence. Like, oh, it's this horrible idea, you're an idiot for thinking about it. Now it's like coming back into play. I mean, how sure are you that it's just bad luck, or was it just bad marketing? I mean, was it the parameters they were using? Did they select the wrong filters? Did they, isn't this the thing everyone's trying to solve, using social media as a platform? So how do I get my message to you, and why isn't my success related to that? Like, is it bad luck, or is it just I did a bad job?
Yeah, I mean, so what I can say, like am really sure about is that there are two components, which is that it's not like if we want to say like maybe we call like there's two dimensions like quality and success. Let's say, all right, so quality is like really how good was your thing, whether it's a message or a tweet you post or some piece of information you're trying to spread, an advertisement, whatever it is. So quality we might think of as like, well, if there was no social influence, if we did focus groups or something, would people really, would this message resonate with them? Would they believe it or whatever? Let's call that quality. And then success is just how much it actually takes off. And so quality definitely correlates with success. Like we know that you're more likely to succeed if you have something better, and less likely to succeed if you have something that's bad. And what the data tends to show is that like the bad stuff almost never succeeds. It's very rare to have something that people individually really dislike, but that somehow takes off. That almost never happens. But what we do see often is that stuff that's really, really good that people could like individually doesn't make it, and that sometimes the stuff that really does make it could be more middle of the road. So there's a huge component that's random, is what I would say. It's very the level of
interesting
how much you can predict it based on quality is really, really low, and so so there's in the skill plus luck equation, there's a much bigger weight on luck than there is on skill. But you do have to kind of have some minimum level of skill, or else you're definitely not going to go anywhere, I guess.
So that's really, really fascinating to me. I feel like retrospective bias is just an innate human feature of our brains. We just make up these stories. We have these results.
Absolutely.
I ended up in San Diego. You ended up in San Diego, right? And we're from 2,000 miles away. And we can make up these stories and how we got here. And I can say, well, some part of that is my ability, intentionality, thoughtfulness of my next moves, my strategy, whatever. I'm not really sure if that's true. I need to believe that that's true because I need to have some kind of sense of myself. But are we just fooling ourselves? How much of this is just, hey, right place, right time, right?
Yeah, totally. I think that's absolutely right. Yeah, I mean, I keep bringing him up, but this guy Duncan Watts has another book called "Everything's Obvious Once You Know the Answer." It's like we can all say that, of course, this was going to happen, whatever it is. But if you actually go back beforehand, nobody could predict what was going to happen. So I think a huge part of it is just luck, random of the draw. You don't have to.
Have you started using Clubhouse or seen it?
No.
Or tried it? I feel like it's part of your job description is to like test out new social networks, but this one is right. It's like you could justify that use of time pretty well. But what's fascinating about this is it's just exactly just a conference call, so it's just audio only. And it's just an app that sits on your phone or whatever. What's funny is people were asking. I've noticed a bunch of doctors on it and a lot of professionals, a lot of cool people in this space, right? So like the hardcore sciences and like physics and everything from that entertainment. And there's like follower accounts and stuff like that. One thing I've noticed, and I said to myself very intentionally when I started using it, I was like, what I'm not going to get stressed about here is the follower count. What I do want to emphasize for myself, like how I'm going to use this app and not get sucked into the typical trap, is I'm going to make it a point to try to connect as cross discipline as I can. So I'm going to have people who are following me who are who are Hollywood producers, and then I've got people we're talking about AI and consciousness at 2 a.m, and they're following. So the friend network, the diversity of interests is really high because I get more value out of that. But that's not something we do a good job of measuring, and I feel like that's a metric. And I was thinking about that. I was like, why don't we measure that in things like Facebook and Twitter? It's like, what kind of people are making up your follow count? Like the histogram is never shown, right? People are not showing that, even though we probably have that data about them. Wouldn't that be more interesting to know, like who is following you? Totally.
That you're exactly right. And there's actually some pretty good research about this that goes back, but pre-social media. When you're trying to look at success of people, like whatever their job is, let's say, one big predictor of their success is some things about their social network, and we call this social capital, right? This is like the value that you get from your social connections. And it turns out that like so this guy named Ron Burt, he went around and measured people's social networks in bunches of firms by basically just asking them, who are your closest contacts, who are your friends, or who do you go to for advice or whatever. And then he would look at how people did, like on their evaluations by their superiors, or how big of a bonus they got for a bunch of financial analysts, or all kinds of stuff like this. And he found that, how big your network was had almost no predictive value, but it's a structural measure that gets at the diversity that you're talking about. So he's only looking at who you're connected. He's only looking at the ties. Like he doesn't know who the people are themselves, so he can't measure whether or not they're different from each other.
Yeah.
But something that gets at that is what proportion of your connections are connected to each other. Okay, so if all your connections are connected to each other, then you're probably like in a little niche. You're probably all ER docs, right, or all network scientists or whatever, and that's how you get that way. But But for you, like you're talking about, okay, I was connected to the AI person and the Hollywood person and whatever. Like those people probably weren't talking to each other, right? Because they're totally different types of people. And so if you have a network that where the percentage of your friends who are friends with each other is really low, you're much more likely to be successful in terms of getting a bigger bonus or getting a better evaluation or pretty much whatever the.
Why do you think that is?
I think it's the diversity. We think that by having access to these diverse individuals, that gives you the chance to transfer knowledge from different areas to your own area, gives you access to different perspectives, it gives you access to more information. So I think those are kind of like our three big three reasons for why that works. And it's a pretty robust finding. Like it's been found in a bunch of areas, and we've got good models for why it works. And I think we feel pretty good about that fact that by building a diverse network or by building diverse teams, you're more likely to be successful. So good strategy, Ravi.
When you say diverse teams, you mean like heterodox thinking. Is that the underlying what you're trying to get at? I mean, like people just basically their expertise and their opinions on things?
Yeah. Expertise and opinions on things, and just also like kind of approaches to problems. Like if you got a bunch of people together to like, let's say you're the president and you're getting your presidential COVID team together, you could just only choose epidemiologists who went to Johns Hopkins or Harvard or like 3 top medical schools, or you could like get some of them and then some people who study networks and maybe an economist in there and a couple people who maybe a regular doctor, an ER doc, let's say, people who have different perspectives and different ways of looking at the same problem, because the idea is just that when one person gets stuck, you want to have someone else who can think differently, and can unstick them. So,
and what's the threshold for disruption there, PJ? You think when you're putting together these teams? Because I found that in my previous experience with startups, for example, a large percentage of what the management team is doing is evaluating people and hiring.
Yeah.
And this seems to be like a super skill that if there was a common pattern among startups that succeed, it's like that ability to get those right people is critical. I mean, you could argue that Elon Musk's real talent is that, right? You could say, hey, he's able to position and place the right people in the right positions to where they're just executing on a vision that he sees very clearly.
Yeah.
Or maybe that vision actually emerges and probably just grows as the products grow and the challenges get they go through meeting these challenges. But where does it get too disruptive?
Excuse me, sorry. You mean like by having too much diversity, you basically like decrease productivity because people don't speak the same language and everything? Yeah.
Yeah.
Yeah, I think that's a harder question to answer. You know, one of the things, I don't know, what do we know about that? Well, the first thing we know is that like when you have a really small team, at the very beginning, you know, it's probably best to start with the people who are the best and not focus on the diversity. And I don't mean, I think identity diversity here necessarily, right? But then as you grow, then you want to try to inject novelty, you know, bring in different ways of thinking. But yeah, I guess I don't have a good answer to that. It comes at a cost for sure, right? It comes at a cost of efficiency, and I think that there are ways of trying to have it both ways a little bit, but I'm not sure it works in the startup world. You know, so for example, with actually, let me not get into that example. It's too. I don't think that's not going to fit quite right with what we're going to say. But yeah, I don't know. I don't have a good answer to that. I don't think anybody does.
How much does your study of complex networks, and specifically since you've delved into things like social networks, how does it just mess with your day? Like when you go, you know, to like a family gathering or like you see your friends and stuff like that, are you just always, are those gears always churning for you? Where you're analyzing the way people are connecting, or when you're watching TV shows or news and things, are you able to just turn that off and enjoy the moment?
Well, I think yes and no. So no, I can't turn it off. I mean, it just changes the way you think about everything. And like, it's just, you know, it's kind of like putting on a certain, you know, colored glasses or whatever, and it just changes the way that you see the world. But it's not like that makes it less enjoyable in a way. It's just, that's just how you think about things. And so I don't even notice it really. You just get used. That's just how it is. You know, when I think about feedbacks and I think about networks when I'm thinking about a problem or what's happening, when I see like what's happening with my kids at school, or the parents who are hanging out outside the school, I think of it and I kind of, it's not like I'm writing down an equation in the corner to solve, but you know, I guess I do kind of see it in those, that the language you have affects the way you think, and so it does change my perspective on things, but it's not a big, it doesn't feel like I'm a,
it's not intrusive. It makes you appreciate the world in a very unique way.
Yeah.
Yeah. No, you're handy able. You're network enabled. So just take me into the current classroom of Dr. Lamberson. So, you know, if I was one of your students, so what is the hot topic that you're currently working on from a research standpoint, but also what seems to be the popular things that you're teaching now?
Yeah, so I teach a bunch of different classes, and they're kind of like all have different different things that people take away from them, but I mean, with the advanced students, we're working on this idea that we discussed earlier about how the digital data gives us new insights into social science. So I'm teaching PhD students about how they actually can go scrape the web for data, and make use of all these new online experimental platforms and stuff to actually do their research, because these are people who are wanting to become, the PhD students, so they want to become professors or researchers in some way. And so I'm kind of hoping to give them some of the skills and get them excited about, like, oh my gosh, wow, there's all these questions we can tackle now. So that's fun. And the undergraduate students, I think that my favorite thing to teach them, and something that I think that they do actually get excited about, has a lot to do with disease spread. But when they learn how they can take mathematics and like understand why something spreads or doesn't mathematically, and especially for students who like come into this, my students are communication majors for the most part, so they're not necessarily coming in thinking like many of them come in thinking they don't have real strong quantitative skills, but for them to be able to say like, oh my god, I can understand this, I think they find that really gratifying and get excited about it. So, but it's probably just because I'm excited about it, and then it rubs off.
That's really cool, PJ. It's something. Math is a language, and it's really intimidating to a lot of people, and me included. It's one of those things where I know I could do it if I just spent the right amount of time and had expert instruction.
Yeah. And
learning how to do it, and I never did that. So it's like I think I fall into this phenotype of people who are like, well, I'm just bad at it. I'm like, well, no, I didn't practice enough, right?
Right.
Not to say I could understand it to the level of things you do, but. How can how can people listening help you? And how do they get involved with working with you specifically, or just what are the interesting topics or ways to be involved in projects? And I mean that in the way of not just even being like leading research, but even just participating in a study at home type of way, if you will, right?
Yeah.
Are there projects going on that they could participate in?
Yeah, that's actually one of the other cool things that I think is happening, is that people are able to get involved. And so there's, let me make sure I get the website right here. So there's a website called volunteerscience.com.
Cool.
And this is just one of the places that's doing this. Let me see if this is who the people are. Yeah, this is started by a guy named David Lazar, who is a political scientist originally. He's at Northwestern University in Boston, and he was one of the authors on the study I mentioned earlier about the 16,000 Twitter users and only 16 of them producing 80% of the fake news links. So they started this, and it lets people, it's a great way for people to get involved actually in research in various ways. And so that's where I would go to start with. There are other things you can do. You can be a experimental subject on the Amazon Mechanical Turk or something, but that's, I think, less gratifying and less like really involved than something like this is, where you can actually kind of get sort of what we call citizen science in a way.
Involved.
And there's other cool projects like that going on. So like, if you're into bird watching, you can, there's like an app called Merlin you can download. I don't know if you even think birds are cool at all. It's awesome.
Yeah, they can fly.
Yeah.
That automatically puts them in an awesome, cool category. Like who when people are like, "Oh, bird brained," I'm like, I feel that's weird. That's an insult. You realize they navigate for thousands of miles with magnetite ore in light receptor molecules around their eyelids. It's pretty amazing stuff, right? So Merlin. So is it a categorization or classification tool?
Yeah, it's like an app that like it just helps you identify birds, but it's like, but behind the scenes, Cornell is collecting all the data, and it's like them being able to field like 100 million graduate students.
Cornell, yeah, they have the largest ornithology database, I think. They've had that for a long time.
This is basically created by regular people, because they used to have to like send researchers out in the field to do bird surveys, but now they basically have like 1 million bird watchers everywhere doing this for them, and they've been able to observe all kinds of stuff and detect patterns. There's another one called Galaxy Zoo. That was really cool. Like they have, they've got like thousands of pictures of galaxies out there, and in the old days they had to have like a graduate student like go through and like code each one. Right. And then now they have like regular people doing it, and because they're able to scale up the data so much, they found all these new discoveries. So you can go get on Galaxy Zoo and categorize some galaxies, and you actually can help people discover stuff. So,
well, I guess I'll leave you with a question of a hard question, but you may have already been primed for this because you've been thinking about it. What is the dream data set? What is the dream complexity problem that you've always wanted to not just work on but solve? Like, what is the one you want the answer to? Answer meaning high predictability.
Nobody has asked me this question. You think it's a question you think about all the time, but like most of the time you're just thinking about what the next step is, in front of your face. I feel like. Yeah.
What's the area that no one's touched, or that someone's just been, people have been trying to work on, like Riemann, like people have been trying to work on for a long time, and just never made any headway. But now possibly we either have the data, computational power, the tools to do it.
Yeah, I mean, for me, I think there are two big problems that I work on for the most of my time, and those are how do things spread, meaning usually ideas or behaviors. And then how do people work together as teams? And both of those problems, data now exists that could give us much, much better answers to those questions. And one of the difficulties is that just a lot of that data is locked inside of firms. It's in Facebook, or it's in Twitter. And, I guess like if there was a problem that I could solve, I think I'd rather solve the infrastructure problem and figure out how we can create an interface between the academic research and those private interests in a way that preserves people's privacy, but allows us to mine that data effectively, because then there's just so many questions that we could tackle. But in some ways, that's a question that we have to answer first: is how can we make it work? And there's big risks for both parties, like with the Cambridge Analytica and all that stuff. It can blow up in your face if you don't do it right. And so I think everybody's but at the same time, like you don't want to be too cautious. You don't want to step away from every question because there are important questions that actually can literally save lives and so forth, that we might not be answering because we're too scared about the data privacy. So we have to figure out a way to make it work.
Nice. Well, PJ, how can people get a hold? This has been fun. I mean, I can keep going for hours, but how can people get a hold of you? Where can they find you?
Yeah, I'm pretty easy to find on the web. If you Google me, you'll find my website. It's social-dynamics.org, and my email's up there. It's just my last name at UCLA.edu. I'm pretty easy to find. I'm on Twitter, PJ Lamberson. I'm not always super responsive. I tend to get behind, especially these days because during the pandemic I've got my kids at home all the time, so I'm spending a lot of time on that, but I'm out there.
Very cool, man. Thanks for taking the time.
Absolutely, it's been fun.